Section 5.7, rational exponents. Now, rational are numbers that can be written as a fraction. As we can remember that fraction is rational. Fractional, rational. They kind of rhyme. Exponents are the numbers that are above the variable. So let's say that if b was raised to the 1 over n power, that's the same as n root b to the first. We have what's underneath goes on the outside, what's on the top goes on the inside, and it's the same pattern. For example, if we had 2 to the 1/2 power, that's the same as the square root of 2. 4 to the 2/3 power is the same as the cubed root of 4 squared. That's going from an exponent to a radical. We can go the opposite way. Let's say, for example, we had the 4th root of a, and we wanted to go from the radical to a rational exponent. We would say that that's a to the 1/4 power. So we can go back and forth there. Now, just like when we had monomials to negative powers, it's the same thing with negative rational exponents. For example, let's say we had 16 to the negative 1/4. Well, the first thing I'm going to do is put that all under 1 as a fraction, and then I'm going to change this to the 4th root of 16. Then I'm going to break it down. 8 goes in twice, 4 goes in twice, 2 goes in twice, and we have a group of 4. So it's actually equivalent to 1/2. Let's say we were simplifying expressions like x to the 1/5 times x to the 7/5. We do the same thing when we have the same bases. We add exponents, so that's actually to the 8/5. We wanted to rewrite that as, this would be as its simplest form because we can't do anything else. You can't simplify 8 over 5 any further, but you could write it from a rational exponent to a radical and say that this is the 5th root of x to the 8th power. Just depends. We can go back and forth between those two answers. But all the rules apply for monomials as they do rational exponents and square roots.